Sierra Space's Dream Chaser just completed every critical milestone at Cape Canaveral. Electromagnetic interference tests, high-speed runway simulations, telemetry systems, all passed. The mini shuttle is finally cleared to fly in late 2026 after years of delays. So why isn't NASA letting it dock with the International Space Station? Dream Chaser's first mission will be a free-flying demonstration in orbit with no station contact. It won't even land at Cape Canaveral. Instead, it's heading to Vandenberg Space Force Base on the opposite coast. What happened during testing that forced NASA and the FAA to completely redesign this spacecraft's mission? Let me take you back to 2010. NASA put out a simple challenge to private companies. Build us a replacement for the Space Shuttle. 3 teams stepped forward with radically different visions. SpaceX proposed Dragon, a proven cargo capsule modified for crew. Boeing pitched Starliner, a traditional capsule design backed by decades of aerospace heritage. And then there was Sierra Space with Dream Chaser, a 9-meter mini-shuttle that looked like it flew straight out of a science fiction movie. Guess which one NASA trusted the least? Fast forward to today. SpaceX's Dragon has flown dozens of successful crew missions. Boeing's Starliner has cost taxpayers over $5 billion and still can't complete a mission without critical failures. Yet Dream Chaser, the spacecraft that just passed every single test, isn't allowed near the International Space Station. How did we get here? Here's what makes Dream Chaser fundamentally different. While Dragon and Starliner are capsules that slam through the atmosphere at multiple G-forces, Dream Chaser glides. It's a true spacecraft with wings, capable of a gentle 1.5 G re-entry that protects sensitive experiments and cargo. The pressurized volume inside is massive, 33 cubic meters split between the shuttle body and its shooting star module. That's more cargo capacity than most resupply vehicles currently serving the ISS. So if it's bigger, gentler, and more capable, why the cold shoulder from NASA? The shooting star module is where things get interesting. This isn't just a cargo pod bolted to the back. It's an independent spacecraft with its own engines, solar panels, and navigation systems. After delivering cargo, Shooting Star can separate and conduct secondary missions. The U.S. military already contracted Sierra Space to use it as a small-scale orbiting platform for experimental defense equipment. It can dispose of space station trash, conduct autonomous operations, or even serve as a temporary orbital lab. What other secondary missions might the military have in mind that NASA doesn't want anywhere near the ISS? During recent testing at Kennedy Space Center, Dream Chaser underwent something unusual. A Freightliner Cascadia semi-truck towed the spacecraft down runways at high speeds, simulating landing dynamics and testing autonomous navigation. This wasn't standard aerospace testing. This was Sierra Space proving Dream Chaser could land like a commercial aircraft on any major runway across the planet. Vulcan Centaur can launch it, so can Ariane 6, New Glenn, and Japan's H-3 rocket. Dream Chaser isn't locked to American infrastructure. It's a truly international spacecraft that can operate globally. Does that flexibility make NASA nervous about control? Then came the runway problem. Someone at Kennedy Space Center, and the original source wouldn't reveal who, expressed serious concerns about Dream Chaser landing on the historic Space Shuttle runway. This runway was engineered specifically for the shuttle's landing profile, perfectly leveled and designed for vehicles re-entering from orbit. The concern? Dream Chaser might damage it. A spacecraft 1/4 the size of the Space Shuttle, using similar landing gear, somehow poses a threat to the same runway that handled 78 shuttle landings. What changed? The answer came through testing data. Dream Chaser's landing weight distribution or approach angle apparently creates stress points the runway wasn't designed to handle. Rather than modify the spacecraft or reinforce the runway, NASA and Sierra Space made a dramatic decision. Dream Chaser will land at Vandenberg Space Force Base in California, not Florida. This isn't just a change of landing site, it's a complete mission redesign. West Coast launches mean different orbital inclinations, different trajectories, and most critically, no flight path over the continental United States. Why did the FAA get involved? The FAA had one primary fear: another Columbia disaster. They didn't want Dream Chaser flying over populated areas during re-entry, concerned about a potential breakup scenario. Never mind that Dream Chaser uses modern materials, has completed extensive thermal testing, and has backup systems the original shuttle never possessed. The decision was final: Vandenberg or nothing. But here's what doesn't add up. NASA still allows Starliner to fly, despite its thruster failures, helium leaks, and the fact that it stranded 2 astronauts in orbit for months. What's really driving these decisions? The electromagnetic testing revealed something NASA hasn't publicly discussed. Dream Chaser successfully proved it could operate in expected electromagnetic environments, receiving telemetry and commands through NASA's Tracking and Data Relay satellite system. The spacecraft communicated flawlessly with mission control in Colorado throughout all test phases. Post-landing recovery rehearsals demonstrated crews could access sensitive payloads within 30 minutes of touchdown, something impossible with ocean landing capsules that take hours to retrieve. Every technical requirement was met or exceeded. So the problem isn't capability, it's politics and priorities. NASA has Dragon for crew transport and multiple vehicles for cargo resupply: Cargo Dragon, Cygnus, and Japan's HTV-X. The agency doesn't urgently need another ISS servicing vehicle, but the Department of Defense sees something different. They see a reusable spacecraft that can launch from multiple sites globally, land on military runways worldwide, deliver or retrieve classified payloads, and operate independently without NASA infrastructure. Dream Chaser is heading back to Colorado for national security modifications before its 2026 launch. What capabilities are they adding that require keeping this spacecraft away from civilian space stations? Sierra Space built components for the HTV-X that just successfully docked with the ISS, Japan's newest resupply vehicle. They've proven their technology works in the harsh environment of space. They've demonstrated reliability across multiple programs, yet their flagship spacecraft, the one designed to carry humans and critical cargo, gets relegated to military demonstrations and free flight missions. The original vision was Dream Chaser carrying astronauts to the ISS, competing directly with Dragon and Starliner. Instead, it's becoming something else entirely. Here's the capability NASA is walking away from. Dream Chaser can reboost the ISS. Its engines are powerful enough to push the station into higher orbit or compensate for orbital decay. This matters because Russia's Progress spacecraft, which handled reboost duties, can no longer launch reliably due to sanctions and supply chain issues. The ISS desperately needs backup reboost capability. Dream Chaser offers it. NASA said no thanks. Does that make sense, or is there a larger strategy at play? The Q4 2026 launch date keeps slipping further as modifications pile up. What started as a commercial resupply demonstration under the CRS-2 contract is morphing into a military capabilities showcase. Sierra Space is caught between 2 customers with very different priorities. NASA wants proven, conventional cargo delivery. The Pentagon wants a flexible runway landing spacecraft that can operate globally with military-grade modifications. Which customer is actually funding Dream Chaser's future? Every milestone Dream Chaser achieves seems to push it further from its original mission. The spacecraft that was supposed to keep the space shuttle's legacy alive is being transformed into something NASA apparently doesn't trust near its space station. Meanwhile, Boeing's Starliner, despite failures, cost overruns, and ongoing technical issues, still has NASA's blessing to dock with the ISS. The contrast couldn't be more stark, and it raises one fundamental question about how we choose which spacecraft get to define America's future in orbit. Here's the bottom line. Dream Chaser passed every test NASA threw at it, but it's banned from ISS docking while Boeing's problematic Starliner keeps getting approved. This isn't about safety or capability, it's about politics and money. NASA already committed billions to Boeing years ago, and those contracts aren't changing regardless of performance. Dream Chaser is being pushed toward military applications because the Department of Defense sees value where NASA doesn't. A spacecraft that can land on any runway globally, carry classified payloads, and operate independently is exactly what the Pentagon wants. The mini shuttle designed to carry astronauts is becoming a military asset instead. Sierra Space proved their technology works. Their components are already on spacecraft docking with the ISS. But in the space industry, proving yourself doesn't matter as much as who wrote the checks first. We're watching a capable vehicle get redirected away from its original humanitarian mission, and the question remains: did NASA back the wrong horse in 2014? Dream Chaser's first flight in late 2026 will finally answer whether this spacecraft can deliver on a decade of promises. We'll be covering every development. If you found this analysis valuable, hit the like button right now. Drop a comment with your take on Dream Chaser versus Starliner. I read every one. Subscribe to New Space Review for space industry investigations you won't find elsewhere, and turn on notifications so you don't miss our coverage when Dream Chaser finally launches. This story is far from over.